Okay. So the first section we covered was actually 3.5, and it was over the rational function. I'm going to tell you a lot of this test is 3.5 because there's a lot of questions from it. It was the largest of the three sections. So 3.5 was on rational functions. And the first thing you got to do with the rational function, or know how to do, is something we did back in 2.6, which is finding their domain. So I would actually go back to 2.6 and look at a few of those questions on how to find their domain. Now, we did this throughout the lecture. If you watch the lecture, you'll see we found the domain for these. That was the first thing we did for all of the rational functions, actually. The first step was finding their domain. And when we found their domain, we knew that if it had a restriction, the restriction could be one of two things. It could be a vertical asymptote, or a hole, right? Those came from the domain. I'm not going to teach these today, but this is just a review that, hey, remember we went over vertical asymptote and hole, and it came from the restrictions from the domain. And then the other topic in that section was the horizontal asymptote, which did not come from the domain. It came from the degrees of the numerator and denominator. Horizontal asymptote. So you're going to have to know how to find the domain and vertical asymptote or a hole, and then know how to find the horizontal asymptote. Now let me make sure. Oh, actually, something at the very beginning of this too was let's see how they labeled it. I'm actually looking at your test right now to make sure I don't forget anything. I know I put something on there. Yes. The rational function. Yeah. I forgot how. Let me get into this section. See how. It was the homework questions at the very beginning of 3.5, and it was about making the statements with the arrows. So I'm going to just give you the homework questions here to focus on, where if I gave you a graph of the rational functions, you have to determine, as x approaches a number or as x approaches infinity, what is the y value? What's f of x approaching? So this is like, this is on page 406, like numbers 9 through 19 odd. Make sure you know how to do those. Now, it actually incorporates asymptotes, holes, and actually not holes, but asymptotes and horizontal asymptotes. But make sure to look at those sections. I've got at least 2 questions on the test, and this test only has like 16, 17 questions on it. Okay, so there's at least 2 from that section, and I know students struggle with this. I'm going to put a little star here because in the past, when I gave this test, the 2 questions from that section really were probably the most missed overall. And then lastly was just the graphs of these, putting all this together. Now you'll have your calculator, so you'll be able to see it, but that will be a part of this test. So that is all of 3.5. That's what you need to know from 3.5 for the test. And you'll see this will be probably it should be the longest list compared to 3.6 and 4.1. You guys have any questions before we go through 6? Any questions from the homework from this section? I don't mind answering any of that fun stuff. So 3.6. Chassie, you got a question? I saw that.
I was just gonna say, when I do sit down and study, if I have a question, would it be okay to email you and ask?
You can always email me.
Okay, I know, but I just want to make sure.
Yeah, no problem. You can always email me, and then I might just point you in a direction. Might shoot you information. Yeah. Sometimes it's hard. If it's on my phone, it's harder to It's hard to help. But if I'm at my computer, of course I can help you a little easier with the document camera. But yeah, no, definitely. If you
I mean,
guys have any questions, please.
video, so I'm gonna obviously just rewatch them too. So I should be able.
Yes. Yeah, and that's another thing too. It is nice. Like right now, you guys. I mean, when you get done here, you can kind of go through, and I would hit if I was going to, rewatch the videos. I would just mainly focus on the examples. I wouldn't go through like all the blah blah stuff I talk about. Just hit the examples and make sure you can go through the examples. Like when I ask you a question on the example, hit pause, work through it, see if you get the same thing. Right?
Okay. Yeah.
That would be a good way to do that. Okay, 3.6, it was really inequalities of the quadratic function. Okay, inequalities of the quadratic function. I'm going to give you a quadratic inequality. So, like x squared plus 2x plus 5 is less than 0 or greater than 0 or less than or equal to 0 or something of that nature. And then you're going to have to solve it out. Now, I want to show you something. I'm actually going to work an example of this because I'm not a fan of how the test generator made the answers. So I want to go over this real fast. So I'm going to make an example just to show you how the book kind of does this. Or actually, it's the test generator. It's not the book. So let's say I had x squared, let's say minus 5x is less than 6, okay? X squared minus 5x is less than 6. And this question will give you the inequality, and it'll say solve the polynomial inequality. Now, it also will say graph the solution set on a number line and express the solution set in interval notation. So it's kind of goofy, and that's why I want to go over it. So we're going to solve this thing out. So if we're going to solve it out, remember, first thing we have to do is subtract the 6 over. And we get x squared minus 5x minus 6 is less than 0. Now, I'm going to do this one without a graph. But remember, all we really need to know are the x-intercepts. So I'm going to set it equal to 0 and find the x-intercepts. Well, this factors into what, minus 6 plus 1. Multiplies to give me negative 6, adds to give me the positive 5, or negative 5, I'm sorry. And I set each one of those equal to 0. And I know my x-intercept. So if I graph this one, it doesn't have to be perfect. Definitely not what we're going for. It crosses, let's use another color here. It crosses at negative 1 and positive 6, right? And is that right? Positive 6, negative 1, yeah. And it goes down really far. It's going to go down really far, actually. And do something like this. If you go graph it on your calculator, you'll see that, okay? But the question asks, where is this less than 0, right? And now it's less than 0 when it's below the x-axis. So it's below the x-axis from negative 1 to positive 6. So in between here, it's below the x-axis. So that's going to be my interval. That's my solution. Now it's less than, so it's not going to include the boundary points, right? Your book called them boundary points. So it would be negative 1 to 6. Okay? Now here's the goofy part. In this test, let's say that's like A. I'm going to fill it in because it's negative 1 to 6. But it's also going to graph a little number line underneath it. And it's going to do this. And I'm assuming it did that in your homework. I didn't look at the answers in the back. But it'll look like that. And then like B, which isn't the answer, might say, might be the brackets, negative 1 to 6. But we know we're not going to be including because it's a less than. But then it'll have the graph underneath it. Negative 1. 6, and it's going to do like a bracket like that, okay? Or C might be the opposites, right? When it's actually above. So maybe C is going to be negative infinity to negative 1, union 6 to infinity. And I'm running out of space down here, but that would be like this. So -1 to infinity. And here's 1 and here's 6. -1, I should say. It'll look like that. Okay. So just realize it's going to have the graphs on there too, but you can just focus on the interval notation and to choose the right solution. Okay. So it looks kind of confusing. That's why I wanted to go over it. And that's just a really good example of it too.
Thank you.
Yeah, no problem.
Pay attention to those negative signs too.
Negatives matter. Okay. Big time. Okay, hold on. Let's see here. Yep, and then so I'll ask you if you like that are just quadratic inequalities, and then we get to 3.5. So 3.5 is going to have a little more information than 3.6. Really, 3.6 is only one type of question. So 4.1 is over the exponential function. Now, the very first thing is just how to put in your calculator. So basic calculator, and what I mean by that, I'm talking super basic, like. If you look at the homework, it's the very first things in the homework. I don't even think I really went over them in class because they were so easy. But it's just knowing how to put an exponential on the calculator. Like if you go to page 451, 1 through 9 odd. Okay, just putting it in a calculator. 2 raised to the pi, like that kind of stuff. If you did the homework, you'll know exactly what I'm talking about, and it was super duper easy. And then I go over an example like the gray wolf one we did in class, where it's just an applied, I'll say an application of an exponential function. So an application of an exponential function, and it's just something to the effect of, hey, we've got this equation that models something, like in the homework, it was an equation that modeled gray wolf population, and X was number of years after like 1980. Well, what does the model predict will happen in 1992? Something along those lines. That's an application example that'll pop up. And then the last part is the compound interest examples. And you've got non-continuous and continuous. Okay, so those pop up, and they were at the end of that lecture in 4.1, where if we're given an example, we've got some principal, we've got an interest rate, we've got the number of times it's compounded each year, we got the number of years we're going to leave it in, pop it into the formula. Now, if it's continuous, it's not going to have a number of compounds per year. It will have to say, this is compounding continuously. That's your clue. Hey, I need to use the continuous formula. And I'll tell you, in the test, which you guys can use your notes anyway, but in the test, it even gives you the 2 formulas. You have to decipher which one to use. Okay, that's what matters. Do I use the continuous example here or the non-continuous example? Okay. One second. I'm just kind of looking through the test right now just to make sure I haven't missed anything. Yep. That is it. That is now there are 17 questions. It's the same as before, multiple choice. You guys have done this. This is not your first rodeo, right? Do you have any questions now that we've gone through these 3 sections? I can give you a few to focus on, like maybe that weren't in the homework. Like if we looked at chapter 3 summary, let me find some in this summary that I like. Hold on. This is on page 437. Page 437. That part. Let's see. Well, I'd like it if they asked you for the domain as well. So if you looked at like 57, yeah, 57, 58. You guys have all the answers to these, so I'm going to give you both here. 59. That's 60. Hmm. Yeah, those are three good examples. But I would also include find the domain for each one of these. It doesn't include that, but I would do that for each of these. I know you're like, well, but the answer's not back for the domain. You're right, but I would find the domain on those three as well. It asks you to find if there's a vertical asymptote, horizontal asymptote, slant asymptote. Don't worry about slant. None of those three will have slant, and we didn't go over it. And then also, if there is one, yeah, then graph the rational function. I can ask a question about holes. Hold on, let's go back. I want to find some more in 3.5 that I think you should look at. So if you go now to, this is for 3.5. You go to page 407. Again, I would do 9 through 19 odd. Okay? Because again, those are the questions that students struggle with. That they're not really math questions. It's just really understanding the concepts. Then I would do 29. Because it's not one, there's not one like 29 and 57, 58, and 59. I'm trying to find some that aren't like these three that might pop up on the test. 29 and 35. I'll tell you it's because they have a hole. And these three don't have any holes. So yeah, those are good. Those are all good questions that might have, they kind of hit all the areas. And then in 3.6, hold on. So back to page 438, which is the review, 69, 70, and 71. Those are three good reviews. So kind of like a way to kind of check yourself. You can kind of treat this like a test. Do those three, see if you get the right answer. It's a good way of checking yourself. And then for 4.1, so page 510, numbers 10 and 11. This is the review for chapter 4, which of course we've only done 4.1, but 10 and 11 are good examples where they give you two kind of investments and you have to decide which one does better. That's a good one. And then we go into 4.1. There wasn't a lot of homework in 4.1, if I remember correctly. So this is for 4.1. On page 450, there's an example. Example 7, it's at the bottom of the page. It really goes to 450 to 451. I would look at that example. That's a good example of what might be on the test. And it mimics a lot of 10 and 11 there. Yeah, and then numbers 53 and 55. 53 and 55, that's on page 452. So these three kind of sections, but this is all 4.1, 3.6, and 3.5 stuff. Okay, so that's a good study guide. Actually, if I was going to make a study guide, I would include all of this on there. And you've got the answers to all of those as well. So if you want to check yourself, you'll be able to.